In this tutorial, we are going to talk about projectile motion. So, what is projectile motion? Projectile motion is a motion in two dimensions. Now, when you say a motion in two dimensions, what do we really mean? So, if we have our xy plane here, and then you throw a ball, okay, from here we throw a ball. Now, this ball is going to be moving in this manner. Okay, so now when you say a motion in two dimensions, meaning that this motion is happening in both x and y direction. Okay, as you can see from here, the object is moving in both x and the y direction. Okay, so that's basically projectile motion. Now, there are three trajectories. There are three types of trajectories which you need to be familiar with. The first trajectory is whereby you stand on top of the building. So if this happened to be our building, then this is the ground. Okay, now if this is the ball, you try to throw it. Okay, so we're going to throw this ball with an initial velocity of 0 meters per second. Okay, so this ball will come here and fall on the ground. Okay, so we are going to have what we call the height of the building, which we're going to call h. Now, we are going to have also the horizontal distance, which we are going to call it the range. Okay, now from here, what we need to know is that we can find the height of the building. We can also find the time it's going to take for the ball to reach the ground. We can also find the horizontal time, sorry, the horizontal distance or the range. Okay, now here what we need to know is that the formulas which we are going to be using, they're the same formulas which we were using under freeform motion. Remember, under freeform motion, we were using these formulas where we said V final is equal to V initial plus GT. The second formula which we had was the displacement is equal to V initial times T plus half GT squared. The third one is V squared final, then is equal to V initial squared plus 2 GS. So now, in this case, when we talk of the S, it's just basically the H. Okay. Now, we're going to see the formula which is going to help us to find the height. But remember, we don't have the final velocity. So the only formula which can work is the second formula. Okay, so we're going to get the second formula, and where there is S, I'm going to put H. So it's going to be the H is going to be equal to V initial plus T. We have this. We have this. Okay, now from here, what I want us to understand is that we are saying that we are going to throw the ball from the top of the building with an initial velocity of 0 meters per second, meaning that the whole of this part here is going to be 0. So our formula is going to be H is going to be equal to half GT squared. So this is going to be our formula which is going to help us to find the height of the building. Okay, now from the same formula, it can also help us to find the time. Okay, so we are saying that we have the first formula which is going to be H is going to be equal to half GT squared. Okay, so this is going to be our first formula. Then now the first formula we need to see the formula which is going to help us to find time. So as you can see, this formula which we have here, if we want to get time, we can just do times 2 the whole of this formula for us to get rid of half the right hand side. So I'm going to say times 2. So 2 times h, I'm going to get 2h has to be equal to, then half times 2, I'm going to get these 2, they're going to be cancelled. So we're going to have g t squared. Our goal is to find time. So we're going to divide both sides by g, and then here by g. Okay, so we're going to see that t squared is going to be equal to 2h over g. Okay, so we can get the square root both sides, and we are going to see that the time is going to be equal to the square root of 2h over g. So in the first trajectory, this is the formula which is going to help us to find the time. The time which is going to take for this ball to move from the top of the building all the way to the ground. Okay, so that is our formula which we're going to be using when finding the time. So let's put it there. We are saying that the time is going to be equal to the square root of 2h over g. Now, what about the range? So when we talk about the range, we are talking about the horizontal distance. So the horizontal distance, in this case, we don't have acceleration in this in x direction. So what's basically happening there is that we are going to use the formula velocity is equal to distance over time. Now, the distance which we're talking about here is the horizontal distance. Okay, so this is the range which we're talking about here. So we're going to say that the distance is going to be equal to v times t. But we need to specify which v are we talking about. Okay, we're talking about the vx. We're talking about the velocity in x direction. So we're going to say that v is going to be equal to vx times t. So this d is basically the range. So I'm going to replace d with the r. So it's going to be like this. So this is going to be the formula which is going to be helping us to find the what? To find the range. Now, in most cases, when you have been given the angle, meaning that we are talking about the vx, but the x component of that velocity, meaning that the final formula is supposed to be v cos theta times t. Because when you talk of the vx, we are talking about this. If we have this, okay. So if this is the angle, so this is going to be our v, then this is going to be our vx, this is going to be our vy. So meaning that vx in this case is going to be equal to v cos theta using SOHCAHTOA. Okay, so this happened to be our formula for finding the what? For finding the range. Okay, so that's what we're supposed to know under the first trajectory. Okay, so now let's go to the second trajectory. Now the second trajectory is whereby this is the ground, and then you try to throw. This is the ground. You try to throw the ball from this point here. So it goes in that manner, then until it reaches there. So let me redraw it. It goes there until it falls there. So let's call this one as point A, this point B, and this point C. So we know that definitely the moment when this ball reaches at the maximum height, it's going to start now coming down. So we are going to have the maximum height there, which we are going to call H max. Okay. So even this one, we are going to have the horizontal distance, which we are going to call the range. That will be our range, which we are going to call it R. Now, we know that the formulas which we need to derive here is going to be the formula for us to find the time. The time is going to take in air. So sometimes they can ask you to find, first of all, we are going to find the time is going to take for the ball to reach at the maximum height. So basically here we are going to throw the ball at an angle, meaning that what we have there is you throw the ball in this direction, then you have got the x and the y direction. So we have this. So we are going to have the initial velocity here. Okay, so we have the initial velocity. So meaning that we have the vx and the vy. Okay, meaning that our vx is going to be equal to v cos theta using SOHCAHTOA. Okay, then our vy is going to be equal to v sin theta. So these are the things which are going to help us. When we talk about the motion in y direction, we're going to be using v sin theta. When we talk about the motion in x direction, we're going to be using v cos theta. Okay, now from there, what we need to understand is that we can find the time which is going to take for an object to reach at the maximum height. But we know that we have those three formulas. Okay, we have v final is equal to v initial plus gt. We have the displacement is equal to v initial times time. We have this. Then the last one is this. Okay, sorry, this one is supposed to be 2gs. Okay, so where s is just basically the height. Now we want to find time. So we know that the formula which can help us to find time in this case, we are going to know the initial velocity. The moment when an object reaches at point B at the maximum height, the final velocity at that particular point is 0. Okay, meaning that the formula which can help us is going to be the first formula. We can't use the second formula because we don't know the maximum height. Okay, same applies to the third formula. We can't use it because we don't know the what? The final velocity, or the displacement, the maximum height in short. So the only formula which can work there is going to be the V final is going to be equal to the V initial plus GT. But we need to specify, are we talking about, we are saying that projectile motion, we're talking about two motions, the motion in Y direction and the motion in X direction. But basically when we're talking about the maximum height, we are talking about the time from A all the way to B, meaning we're talking about the motion in Y direction. Okay, now the motion in Y direction, meaning that we have to specify which velocity are we talking about. We're talking about the Vy final is equal to Vy initial plus GT. But remember, when an object is going up, the value of G is negative. When it's coming down, the value of G is positive. So now, since it is going up, meaning that the G value has to be negative. Okay, now, what is our Vy final? The Vy final here, we can see that the final velocity at that particular point when it reaches at point B is going to be 0. Okay, so it's going to be 0. Then this this V initial we have, but we say that the Vy, where we see Vy, we're going to replace it with V sin theta. So it's going to be V sin theta plus, then the G value is going to be negative times T. So I can shift V sin theta to the other side. I'm going to have negative V. I'm going to have negative V sin theta has to be equal to negative GT. Let's divide both sides by negative G. Divide both sides by negative G. Okay, so we can see that our T, we're talking about T from point A all the way to point B. Point A to point B. Okay, this is going to be equal to, the negative and negative will go, is going to be V sin theta divided by G. Okay, so this is going to be our formula, which is going to help us to find the time for that ball to reach at the maximum height. So we have A all the way to B is going to be equal to V sin theta over G. So this is going to be our formula. Now, we know that we are talking about projectile motion, whereby we can also find the time from A all the way to C. So now the time is going to take from A all the way to B, and the time is going to take from B all the way to C is the same. Therefore, for us to find the time which is going to take from A all the way to C, meaning that this is going to be equal to, we need just to do times 2. So it's going to be 2 V sin theta divided by G. So this is going to be the time it takes for the trajectory to be in air. Okay, so now I can just put these formulas here. Okay, let me just put these formulas here. We are saying that the time from A all the way to B is going to be equal to V sin theta divided by G. Then the time is going to take from A all the way to C. This is the same as they're going to be asking you to say the time the ball was in air. Okay, so we have this is going to be equal to 2. We need just to do times 2 this formula. V sin theta everything divided by G. Okay, now we can also find the formula which is going to help us to find the maximum height. Okay, so which formula do you think it can help us to find the maximum height? Okay, so now from those formulas I listed earlier, we need to find the formula which is going to help us to find the maximum height. But remember, we are going to assume to say we don't have time. Okay, meaning that the only formula which can work is the V final squared is equal to V initial squared plus 2GS. So now where S is just basically the H, the maximum height. We know that when the ball reaches at the maximum height, the final velocity is 0. So this part here is going to be 0. But before we do that, we need to specify which velocity are we talking about. We're talking about the V y final squared is equal to V y initial squared plus 2GH. So we're talking about the velocity in Y direction. Okay. So now what we're going to have there is this part here is going to give us 0. So we're going to have 0 squared is going to be equal to this Vy is going to be V sine theta. So we're going to put V sine theta. But it is squared, so we have to square it. Okay, plus 2. The G value is going to be negative. We have plus 8 times H. So I can shift this part to the other side, meaning this 0 is going to disappear now. So we're going to have negative V sine theta. Everything has to be squared. It's going to be equal to 2HGH. So we can divide both sides by negative 2G, even here by negative 2G. Therefore, our formula is going to be equal to, the final formula for calculating the maximum height is going to be like this. The H max is going to be equal to, we have got the V sine theta, everything has to be squared. Negative and negative will go, so we're going to have 2G. Now, this is the same as just saying we distribute the squared there is going to be the same as the H max is going to be equal to V squared sine squared theta over 2G. But I encourage you guys to plug in the values from here. You can just plug in the values V sine theta, then find the answer, then square that answer. Sometimes you might have challenges on how to plug in using this formula. But if you know how to plug in this formula, it's the same thing. Okay, so that is the formula which is going to help us to find the maximum height. Okay, now another thing which they're going to ask us here is to find the range. Okay, so now let's put this formula here. We are saying that the H max, we have the H max, which is going to be equal to V squared sine squared theta, everything divided by 2G. That is our maximum height. Okay, now let's get to understand, or let's get to know the formula which is going to help us to find the range. Now remember, we said that range is given by Vx times t. But in this case, the time which we're talking about is the time the ball was in air. Meaning we're talking about this formula here. That is the time which we're going to be using. Now, the Vx is just basically V cos theta. So I'm going to say that V is going to be equal to V cos theta. Then times, the time which we're talking about here is this formula. Okay, that is the formula which we're talking about. Meaning that I'm going to replace time with 2V sine theta, everything divided by G. Okay, so I can simplify this formula and say the range is going to be equal to, we can say that V times V is going to give us V squared. Then I can put 2 here, then I have cos theta times sine theta, everything divided by G. Now, this part here which we have, this part here is a trig function. That is what we call, we have got a trig. So now what is happening there is that if you have got 2 cos theta times sine theta, this is the same as sine 2 theta. So what I'm going to do is I'm going to replace where there is this part here with sine 2 theta. Okay, then I'm going to go there and say I replace that guy with him. I'm going to say that my range is going to be equal to V squared, then we have sine 2 theta. So this is going to be my formula for calculating the range. Okay, so now we can put this formula, let's put it here on top. So we have there the range, which is V squared sine 2 theta over G. Okay, now we need also to know another thing which we need to understand here is they are going to ask us to find the velocity just before it hit the ground. So what we need to understand here is that this trajectory, the way it is going in this manner. So the moment just before it hit the ground, you are going to have the motion the velocity in y direction and the velocity in x direction. Now, the velocity in x direction, it is the same as the vx, which we said v cos theta, which is not going to change. But what about the velocity in y direction? To find the velocity in y direction, we are going to use this formula. We are going to say vy final is going to be equal to the vy initial plus gt. Okay, now what we need to understand here is that we are talking about this trajectory coming here. So we know that the final velocity now is going to be the initial velocity. Okay, so meaning that the initial velocity at this particular point is going to be 0. So this part here is going to be 0. So the formula which we are going to be using is going to be this gt. Okay, but basically what we need to understand is that that velocity is going to be negative because it's going in negative y direction. So we are going to say that our vy final is going to be equal to gt. This formula, when we find the answer, the vy, to get the velocity just before it hit the ground, we are going to get the magnitude of that velocity is going to be the square root of vx squared plus vy squared. The vx which we are talking about is this vx which we have found here. Then the vy is the one which we are going to get it here. But remember that the vy is going to be what? It's going to be negative. Okay. Now, if the vy is going to be negative, they can also ask us to find the angle which is going to form just before it hit the ground. Meaning that you know that this is going to be the same as tan theta is going to be equal to vy over vx. So it's going to be theta is going to be equal to v, you say tan inverse vy everything divided by vx. Then you plug in the values for the vx and vy. Okay, so those are the basic things which you need to understand in the second trajectory. Now, let's talk about the third trajectory. Now, the third trajectory is whereby you stand on top of the building. Okay, so this is the building. So this building, you're going to have the height of this building. And then you throw the ball at an angle. Okay, you throw the ball at an angle. This is the ball, and then you throw it in this manner. Then it goes there until it reaches the ground. Okay, so this ball is going to be thrown at an angle. We are going to have theta there. You have the initial velocity. So the third trajectory is the combination of the second trajectory, the first trajectory, and the second trajectory. Remember, we said that the first trajectory was just basically you throw an object there, it goes there. Then it's more like we add now this. Okay, so it is just the combination of those two things. Now we are going to have the maximum height. Our maximum height is going to be the addition of the maximum height, which is going to be here. That height we are going to call it the h max. So, or let me just put it the small h. Okay, so that small h plus the capital H, that will be our maximum height. So if I do h plus h max, it's going to be our maximum height. Now, how do we get to find the maximum height? Remember that for you to find the small h, that is the second trajectory now, where we found that the formula was h was equal to v squared sine squared theta over g. Now, when you get the answer here plus the h which you are going, this h you are going to be given always, plus the h which you are going to be given here, that will be our what? Our maximum height. So in short, it's just a matter of us finding the h and then we add it to this capital H, and then that will be our maximum height. Okay, now another thing is how can we find the maximum height? Is just a matter of us using this formula, like I said, v squared sine squared theta everything divided by g. Oh, 2g, sorry, not g, but 2g. That is the formula which we found in the second trajectory. Now, we need to also to find the formula which is going to help us to find the time. So let's denote this part here to be our, let's say this is our A, this point is B, this point is C. So this part here is the maximum height where the final velocity is going to be 0 at that particular point. So to get the time, the formula which I'm going to show you here, I want us to find the time from A all the way to B. Now, the time from A to B, we know that it's just basically in second trajectory we found that this was V sine theta divided by G. Now from B all the way to C, it is just a free form motion where we are going to have this. The maximum height is going to be equal to the V initial times T plus this. Now the initial velocity at this particular point, this point is going to be 0, meaning we don't expect to have this point here. So we are going to have H is going to be equal to we are going to have half gt squared. Now the h which we are talking about here is the maximum height. This h here plus the h which we are going to find here, that is the h we are talking about. So in short, I can just say it is the h plus the comma small h, and then I'm going to say that this is going to be like this. So our goal is to find time. So now let's just put h plus this to say this is going to be the h max. Okay, then let me replace h plus h with what? H max. So let me put this one as h max, and then our goal is to find time. So now to get rid of half, we are going to do times 2 everywhere. We are going to say it's going to be 2h max is going to be equal to gt squared. We divide it by g. We are going to say that we are going to have t squared is going to be equal to 2h max, everything divided by g. So we get the square root of both sides. We are going to say that the formula which we are going to get here is going to be this. It's going to be our t is going to be equal to the square root of 2 times h max, everything divided by g. So this is going to be the time from C all the way to, or from B all the way to C, from B to C. So we have just to add these two guys. Okay, so if we add it, we are going to have the total time. So we're going to say that the time from A all the way to C, the time from A to C is going to be equal to, we are going to have V sine theta divided by G plus the square root of 2h max, everything divided by g. So this is going to be the formula which is going to help us to find the time in this type of trajectory. Okay, the next thing which we need to know is how do we get to find the range? Okay, so like I said, the range, so let's put this formula here. We are saying that t from A all the way to C is going to be equal to V sine theta over G plus the root of 2h max divided by G. Now from here, what we need to understand is that we can also find the range. The range is just basically the horizontal distance. So we have, this is going to be our range, since I don't have space that side, but I'm talking about this. So the range is always just equal to Vx times t. So now we know that this Vx is just basically V cos theta times t. Now this t which we are talking about, you are going to get the t using this formula which we have found here. Okay, that is going to be our range. Now, they can also ask us to find the velocity just before it hit the ground. The velocity just before it hit the ground in all the trajectories, the formula is the same. You get the Vx and the Vy. Okay, the Vy using the formula, Vy is going to be equal to the g times t. So then you need to get the magnitude of that velocity, where you get to use the formula which is going to be V is going to be equal to Vx squared plus Vy squared. So you can also find the angle using the formula theta is equal to tan inverse open brackets the Vy over Vx. Okay, so these are the formulas which we need to get, or which you need to know under projectile motion. Okay.